spent so much of his life trying to tame the spaghetti monster that is this big chunk of code where we have a million different ways of maintaining state and updating pieces.
All right, how you guys doing? Yeah, so my talk is on state management with React hooks. My name is Eric. I am a developer advocate for Kendo React with Progress. And yeah, thanks a lot. Before that, I was a software engineer at Tesla and Solar City, mostly a UI engineer. And like he said, dealt with a lot of legacy code bases. And one of the things that kind of turned me on to React was when we got acquired by Tesla, we had to give a presentation to the higher-ups at Tesla and show some of the components, both in Angular and React, that we were developing at Tesla. I was building Angular applications. My buddy was building React applications. And he gave a presentation in Storybook that just blew ours out of the water. And so that was my kind of first introduction to React, and also was kind of the catalyst of me moving from Angular to React. And then once I got to know React a little bit better and started to learn about the one-way data flow and set state and all this stuff that kind of helps you manage state, it was a no-brainer to kind of move over. So the first thing I want to start with is just a little bit of a history of React state, and I've had to go back and learn some of this myself. So if I don't get it completely right, you know, give me a break. But you know, when React was released back in 2013, set state was already around back then. So from the beginning, React has been a framework that helps you to deal with state management. Some of the other main points in this timeline here are the release of Flux at F8 in 2014, which was, if you know much about the Facebook issue with their messaging, where they had problems keeping that state up to date. Flux was one of the things that helped them tackle that. And then in 2015, Redux was debuted at React Europe by Dan Abramov. And that was just kind of Flux kind of reimagined with reducers. And I put React Fiber on here because one of the things that I've noticed about React Fiber is whenever it was released, that was the initial 16.0 release of React. And I think that that set in motion a whole lot of changes in React that maybe we don't know about or we've seen over the last year and just didn't really attribute to React Fiber. So React Fiber was a complete rewrite of the internals of React, and they kept parity with the old API, which was really good. And I just think that that set up a lot of developer experiences that we've seen out this last year, like React Lazy, React Suspense, being able to do context API with hooks, and of course the release of hooks in 2019. So yeah, 16.8, that was the release with hooks, as most of you guys know, back in March. And I always tell people that if you really want to get an idea of how to work with hooks, you know, definitely go read this article as well. Go check out the documentation on reactjs.org so that you can learn, because it's really easy. In about 2 hours, you can go through the entire documentation and you're up to speed with hooks. A little bit of a spoiler, there's 4 major rules in hooks. Never run a hook inside of a loop, condition, or nested function. Hooks want to sit at the top level of your component. You should only call them from functional components, and you should never call hooks from a regular function. So if you want to actually implement these in your code base and get warned if you're breaking any of these rules, there's a good ESLint plugin that you can find by going to the reactjs.org documentation on hooks, and you can install that, and then anytime that you do one of these silly things like put a use effect inside of a conditional, it will warn you about them. So if I had to explain React hooks and kind of what it is, it's a stateful primitive, simpler than a class component. It allows you to write, contain composable behaviors, easily share code, and maintain state. And one of my favorites is it allows you to kind of co-locate your code for your effects in separate effect statements. So instead of having all of your code bunched up into component did mount, component did whatever, you can put them into separate effects, which I really like. Again, if I had an elevator pitch, if I had to just explain really quick, access to state from functional components is kind of the main thing with hooks, although that's just one of the things that you get using useState. Cleaner and more concise code. It can help to solve the wrapper hell encountered with nested render props and higher order components. It'll remove duplication of logics, like I just said in your lifecycle methods. and help you co-locate that code into your effects, into your effects. But the best way really to start learning about hooks is to just dive in and look at some code samples. So that's what we'll do now. We'll start with useState and just look at some very simple canonical examples that you can also find in the reactjs.org documentation. So this here is a simple counter example, and we're using a class, and we have to have a constructor, a call to super. We have to understand when we're using this and kind of what it refers to. If we use handlers on top of events, we need to make sure that we bind those in the constructor if we're dealing with anything that uses this inside of the body of it. So these are all things that you have to keep in your head when you're dealing with a class component that can be a little bit daunting or a little bit just too much overhead. Now, this is what the same hook looks like. So, or same functional component with a hook. So clearly, this scales up pretty well. So I'm going to blow this up a little bit for you so you can see it, because another thing that I tell people, one of my favorite features about hooks is it allows you to show slides at a higher font. All right, so use effect. Some of us know about the lifecycle methods in React. If not, these are things that allow you to, if you're fetching data or you're subscribing to something or needing to unsubscribe, you're going to put code in different lifecycle methods in order to make sure that things fire off at the right time in your lifecycle of your component. So let's get into some examples of that. So here was the hook that we had from before in a small font. Sorry about that. And then if we want to add an effect to this, it's very easy. We just add useEffect. And so one of the things that useEffect is good for, or the way I like to think about it, is this is where you put code that you want to do something with outside of your application. A lot of the time this is dealing with the API, it's dealing with local storage or things like that. But the easiest way to kind of show how this works is, or to play around with it, is just to change the document title. And again, this is something you'll find in the reactjs.org site and in all the examples that they have. And so pretty much, useEffect is going to run every time that this component loads or mounts or changes, and that document title is going to get updated. So basically, in this button, every time we click to increment that count, we're going to experience a refresh of the page or of the component, and we're going to fire off this useEffect. And when I show a demo a little bit later on, I'll show you some of the things that you can do with useEffect if we have enough time, and I think we will. So yeah, that's pretty much useEffect. This is what that same code looks like if you want to do it in a class component. So let's go back and forth here real quick. Functional component, using hooks, using useEffect. Class component. So about the only thing you don't have to do in a class component is import, the extra useEffect and useState. But this is a little, again, it's a little bit more that you have to keep overhead in your head as well. We're repeating code here. So this document.title, you clicked whatever times. Of course, we could put that in a function or whatever, but I left it like this just to show that we're duplicating code and we're duplicating efforts here and doing the same thing in two different lifecycle methods. And that can all be tackled with one useEffect. The cool thing about useEffect too is you can have as many of these useEffects on one component as possible. So you can have 10 of them in there, and that's the thing that I told you. If you want to co-locate code, let's say you have a lot of things that go with data fetching, then you have something that updates the document title, and then you have something else that updates local storage. You can have them all in their own useEffects, and each one of them can have either an extra parameter passed in or a return statement that helps for cleanup. So you can do a lot with it. It's very, very versatile. That's kind of what it looks like up close, so you guys can see it. Again, hooks allows us to use a bigger font. Nice. All right, so one of the other hooks that I want to talk about with you guys is useReducer. But before we get too far into it, I just want to do a little bit of refresher on what a reducer is. So before we had Angular and React and all this stuff, we did a lot of just JavaScript programming on its own, and I used reducer a lot. So reducer is just a method that executes a reducer function that you provide on each element of an array, and it results in a single output. So one of the things that you can do with a reducer in plain old JavaScript is you can have an array like this one, votes by district. Let's just say this is the number of votes cast in each district of a state or something. And you can set up a reducer. And what this reducer is going to do is it's going to return a sum. And you can see here in the first example, we say votes by district, reduce, we call it a reducer. And obviously, that's just going to calculate the total of all of them, right? And it's going to keep on passing back to itself over and over until you result with a final result. Now, the second one here, I wanted to provide this example because if you use useReducer and hooks, it uses the same kind of pattern as we did with the old reducer. So if you know reducer, you kind of already understand how useReducer works in hooks. So what is that 55 as a second argument going to be passed in? It's not going to add to it. It's going to create a starting value, a default value, right? So then if we start at 55 and then we add them all up, we get 555. Same thing with useReducer. That second argument will be a default. Something a little bit different you can do with a reducer. So here's a list of to-dos, and each of them have a priority. So in this reducer, what I'm doing is I'm running through each of the to-dos. I'm deciding if that to-do that I'm currently on was higher than the last log priority or the highest log priority, and if it does, I replace it. If not, I don't. So at the end of the day, at the end of this reducer, I'm going to be passing back not a total of all the priorities, but whichever object of that, whichever to-do had the highest priority. So again, another thing that you can do with a reducer, reducers are very versatile. You don't have to use them just for summing up, calculations. You can use them for different things as well. And the same thing with useReducer. You can get creative and use it in different ways. So as we said, useReducer is kind of the hooks version of reducer, and it's kind of an alternative to useState and preferred for more complex state involving many subvalues. So the one thing I'd like to try and explain to people when you would use useReducer versus useState, if I'm just tracking a Boolean value on whether or not a side navigation is open or not, right? That's something I can use useState for. I'm only going to ever change that value one way. I'm going to flip it from false to true and true back to false. useState is fine for that. But what if I have a list of to-dos, and I want to continually update that list of to-dos? I want to add a to-do, I want to delete a to-do, I want to clear all of the to-dos. I'm sure there's another one in there somewhere. The idea is that I don't want to just have one way of updating that value. And in useState, you have a tuple that's returned, which one value is the actual local state value, and the other one is a way to update it, a function that you can use to update it. So with a useReducer, instead, we're going to, our second item in the array is going to be dispatch. So we can just call dispatch and pass like an object to it, and that object can have different types, and then inside the reducer, we can switch on those types and decide which set of code we're going to run depending on whatever that type is. So if it's an add to do, it goes into the reducer. It says, okay, the type is add to do, so we're going to spread out the state and then add one to the end of it. This is kind of what it looks like if you were to look at a flow of useReducer. You've got a dispatcher. That dispatches an action, goes to a reducer. The reducer returns new state. This is also what it looks like to write a reducer for this is actually exactly what the to-dos reducer looks like inside of the demo I'm going to show. And you can kind of think of it like this. You have a dispatcher. It dispatches an action. That action is passed to a reducer, in this case, to-do reducer. That returns a new state, and that new state is available in your to-dos local state object. All right. So what we're going to do is we're going to try my live coding skills here. But thankful for you guys, I have a bunch of snippets set up, so you guys don't have to watch me type. Hopefully it'll go pretty smoothly. All right. Let me go ahead and spin this guy up and show you guys what we're working with here. Oops. I got to put a space there. All right, so this is going to be our app. It's going to be a simple to-do app. And this is also something I'm going to be giving away in my, not giving away, but making available through my slides and my resources link at the end of the application, or at the end of the talk. So this application is a project with routing. On the home page, it has the example of the clicker that we were talking about. We showed the examples for. As well, I have a functional and a class version of that inside this project. We also have this to-dos area here. And everything I've done in this project, I've tried not to use any additional components. I've just tried to use raw HTML and semantic HTML so that it's very easy to work your way through and figure out how it's all set up. But yeah, you can resize this. You've got some responsiveness going here. So I've got a breakpoint that I switch on. If it's a small breakpoint, we hide the menu. If it's not, we show it. Also, if you open this guy and then try to make it, oops, we don't want to do that. Make it bigger, it'll go away. So I'm using hooks for all this. This entire project is set up using functional components and hooks throughout the entire thing. So it'll be very interesting to go through after the conference and take a look at it. I'll show you really quickly kind of how it's set up. This is the main app.js. So this use media predicate is someone else's hook that I brought into the project, and that basically watches the breakpoint. And what I've said is, watch minimum width 600 pixels. If it's min width 600, I want false, otherwise true for this variable here. And then I can switch on this guy, or not switch on, I can provide either medium or small as a class, and that'll be useful for anything that's below that element to decide to use certain CSS or not based off of that's medium or small. So that's a very interesting way to use a hook. We've got a browser router in here. This app provider, if we go look at that really quickly, is actually using useState. And this is what I love about what hooks has made possible with the context API, is that all I'm doing here is tracking whether or not the nav is open or not. It starts as false, and whether I click that button or not, it changes this value. And I change it through this toggle side nav. And the fact that I have this set up like this, if I go to, let's see here, menu, I think. So menu imports this context and uses context as a hook. And now I can in here just say context.toggle side nav, and whenever I click on that button, I can change that value. And then everywhere in my app gets notified. And we can do that by just using context this way, instead of having to wrap a consumer around the parts of the code that I want to use that. So that's interesting. So what I want to show you guys is how to quickly create a to-dos page, and we're going to do that. So right here, this doesn't work yet. If I click on these, it should change it to completed, which it'll just dim it out. If I click X, it should get rid of it. If I clear, it should get rid of all of them. And if I type something in here and hit enter, it should actually add one to it. So just watch as I add some of this code here. So this right here is just, we're actually going to also redirect the page anytime that we hit clear. So let's talk a little bit about the code I just added here. So we're going to track, we're going to use both useState and useReducer. useReducer will take care of our to-dos object and allow us to change those to-dos. ToHome will just keep track of a Boolean value, and if it gets set to true at any point, we're going to redirect back to home. The useEffect, we've already kind of talked about that and what it does. So a few things we're going to need to do here is we're going to need to add an input reference. And that's a hook also. We'll go ahead and add this too. So this is simply going to watch if ToHome ever becomes true. We're going to render a React router redirect back to home. Interesting way to use a hook. And now let's just go through, one more thing to show you here is that so whenever you submit that input, it's going to call add to do handler. When we click on the actual to do, it's going to do this toggle complete handler. When we click on the X, it'll do delete to do. And as well, when we click on the clear to dos button, it will clear out all the to dos. So let's go ahead and see what we need to go ahead and finish this up. So on add to do, all we really need to do is prevent the page from refreshing because we've submitted some text in an input, and typically a form submit will cause the page to refresh. So we want to prevent that. As well, we want to dispatch a object with an add to do type, and we want to just set the name as whatever the input reference current value is. As well, we're going to set complete to false at the beginning because we don't want any of our to-dos to be rendered as done when we initially load them. The next thing we're going to have to do is we're going to have to go over to the to-do reducer, and instead of returning null, which isn't going to do anything for us, what we want to do is we want to say, hey, is the action name available? If so, what we're going to do is we're going to spread out the current state, right, all the to-dos, and we're going to add them, and then we're going to append one to-do onto the end. We're going to determine its ID based on state.length. We're going to max that and figure out what the next ID is. As well, we're going to take action name and action complete and add those here. So this will just return any to-dos that are currently in the state and append the new to-do onto the end. So our reducer, the only job that this reducer has to do is return our state in the proper way. That's it. So if we go back over here and save this, hopefully, oops. That should work now. Cool. So it adds one. Great. Next thing we need to do is we need to go ahead and do the toggle complete. And you know, I'm going to go ahead and fill all these out real quick, just for time, because these are all pretty much the same, right? Since we're not adding a new to-do here, all we're doing is toggling one, deleting one, or clearing all of them. All we really have to do here is dispatch an object with a type in it, nothing else. And an ID for toggle complete and delete to-do. As well, on clear to-dos, after we dispatch it, we're going to do a little set timeout and then call the set to home, set it to true, so that we have a little 2-second pause before it redirects. Now, if we go back to the reducer, we got to go ahead and fill these out too. We got to make sure they're returning the right state here. So when we toggle a to-do complete, what we're doing is we're just returning the state mapped, and we're saying wherever the ID, the action ID equals the current ID, we're going to just flip its complete value and return it. And then for all the ones that don't match that ID, we're just going to return the to-do as it is, right? We all know how map works. So what this will do is it'll give us the whole list of to-dos back with just one of them flipped. This one's pretty similar too. We're going to do a filter here. Oops, wrong one. Sometimes. Oops. Yep. All right, so on a delete to do, we're basically just going to filter through the current state, and anywhere that that ID matches, we're just going to remove it and return all the state, right? So this is all very easy stuff. And then clear to do's, what are we going to do? This is easy, guys, come on. Turn nothing, right? Just set it to nothing. So now we've got all of our to-do dispatches set up, our handlers and dispatches. We've got everything set up here. And it's a nice, everything's really easy to read. You know, I could use some formatting up here or whatnot, but whatever. So now we should be able to check them complete. We should be able to remove one, add them, and clear them. 1, 2, redirect, right? So, yeah. And then what I also want to show you is what this file right here looks like as a class. So let's scroll the way down here, because at the end I have like a nice little comment here, which shows how many lines and how many character count it is. And then if we do this, let's pull this one up. Let me go ahead and make that a little bit bigger for you. So we'll see as we scroll down here. Just a little bit more going on, right? Also, we have to manage kind of what happens with set state, right? So this is something we don't have to do with the reducer, right? Or actually, we're using a reducer here on this one, but because we're using a class, we've actually got to do the set state ourselves and understand kind of, it just makes it harder to do. More stuff to think about, right? Not much difference down here, except for the reference to this. So the difference is 61 lines versus 81 lines, 1,484 characters versus 1,823. Now, I'm not saying that's anything major, but it's a reduction in the amount of code that you write. It's less overhead that you have to care about. And at the end of the day, it's, this scales when you have a big code base. And again, one of the reasons I love React is the fact that it has a clear way, a clear opinion on how you should manage state. And it has since day one. And everything that they've done in React over the last few years, I feel like a lot of people have given React, have kind of picked on React because it wasn't as much of a framework as Angular was or whatever, but it's becoming a little bit closer to a framework. I'd still say it's a library, but they've thought through all of these things a lot, right? The laziness, suspense, and hooks, and state. They've really thought about it, and by the time it hits React, it's pretty well fleshed out, and they're good opinions. They're not bad ones. And it doesn't leave them up to the developer either. So I like the fact that state, they have a very, very opinionated way of doing it, and I think that way is the right way. And it's one of the reasons I'm a React developer. That's pretty much, yeah, because I don't want to manage state, really. I like the idea of making sure that I'm returning the right state and doing that, but I'd rather a lot of the internals of that be managed behind the scenes, because when that's left up to me, a UI developer, it's not going to go too well. It's going to become spaghetti code. And that's a lot of the problems I've had in the past with legacy applications. And yeah, so write slow, take your time, because a program or an application that you take your time and kind of think things out and have opinions like these where it's the right opinion, it's the right way to do things, you're going to end up with a nicer application, easier to read application, and that means that the guy that you hire next month is going to be able to come in, get acclimated with the code really quickly and be able to do a good job and not be trying to figure out for a week how to change the state of something. Anyways, that's my talk. Thank you very much.